Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 1 of the unit motion in a straight line. This is a introductory section as well as you have gone through this in class 9 as well. So let's revise this. So let's beginning with the introduction. What is motion in a straight line? Look at this car and this is its path. As the time will going, this will move in this direction. So this is what we call as a motion in a straight line. Now, but the thing is, we need to discuss about this two people. One is particle, another is the rigid body. Now first, what is particle? We can say that a particle is an object which is having a negligible dimensions. A particle is an object which is having a negligible dimensions, then that object can be considered as an particle. And what is a rigid body? We can say that it is a combination of particles. Look at this, it's a combination of particles, and when an external force is applied, there will be no change in its dimensions. If a body does not change its dimensions, even though a force is applied on that, then that body can be considered as a rigid body. Are you clear with this too? It's a particle and rigid body. Particle is the one which are having a negligible dimensions, and the rigid body is the one that we can say it's a combination of particles, as well as when an external force is applied on it. When an external force is applied on it, it will not ready to change its dimensions. That is what we call as a rigid body. Now question arise in your mind would be that, sir, I would be a particle or I would be a rigid body? Think. So what you can consider is, if relative distance is less, look at this man and this girl, the relative distance is less, you should be considered yourself as a body. This is boy, this is girl, their relative distance is smaller, and at this point of time you need to consider yourself as a body. Then when I should say myself as a particle, let's look at this. Suppose some people are there sitting in an aeroplane. You are here and wondering that why people are going and where they are going. But let's come to the point. When this people will observe you, the relative distance between you and this people is very large. At this point of time, you need to consider yourself as a particle. Are you getting it? Yes? Okay. So we have done up to the particle and rigid body. Now the next very interesting things are the rest and the motion. Rest and the motion. First, what is rest? Look at that television set. It is at rest. Look at this table fan. It is at rest. So how could I say that certain objects are in rest? What should be the conditions so that I can call a certain object that this objects are in rest? So if I want to define it, I can say that if a body does not change its position with respect to surroundings, then the body is said to be at a rest. If a body does not change its position with respect to the surroundings, then this body is said to be at a rest. Now look at this situations. Can you see blades of the fan are moving? Can you say this? Yes. Can you see the moving car? Yes. So if you observe these two things, or moving blades of a fan or a moving a car, this both changes the position with respect to time. This people are changing their position with respect to time. That's why they should be known as that they are in the motion. So are you clear with the rest and motion? Are you sure? If you are not supposed to change your position with respect to surrounding and with respect to time, you are said to be in a rest. If you are changing your position with respect to time and with respect to position, you are supposed to call yourself that I am in a state of motion. Are you clear with this? Let's look the new case. Look at this. Certain people are there which are sitting in the bus, and this bus is moving. It would be moving in this direction. Then what should I say? What should I say about the passengers that are sitting over here? They are in a state of rest or in a motion? What should be the correct answer according to you? What should be the answer? Yes, let's look. If I consider only the passengers, if I consider only the passengers, then I can say that passengers in the bus are at rest relative to each other. If I look at the person 1, this is person 2, this is person 3, this is person 4. Everybody was sitting at their place before buses started, and while assuming that they are not moving in the bus while bus is moving, then this all are relatively at rest with respect to each other, so they can be considered in a state of rest. While if I look at this passengers, if I look at this passengers according to this people, according to the people at a bus stop, they will say no, 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 you are not at rest, you were at motion, because as this person, this passengers have changed their positions. So again confusion would be the passengers in the bus are at a state of rest or state of motion. So let's get it clear by an example or by an concept of frame of reference. But before going through this, let's summarize a little. First, we know that what is rest. Then I can answer is, if a body is said to be at rest when there is no change of position with respect to time. Then someone asked me that what is motion. I should say motion is change of position with respect to time. It is a completely opposite to the rest. Now where we study this rest, motion and different kind of motions and all this, we can say it's a branch of mechanics that deals with the study of motion of object without any reference to the cause of motion. This is very very important. That is called as in kinematics. So when I say kinematics, what I mean is I need to study only the motion. I need to study only the motion. I am not interested. I am not interested in study of cause of that motion. I am only interested in the motion, that how particle is going, how particle is moving, what is in motion, what is at rest, and so many things. But I am not going to discuss anyhow that how this motion arises, why this particle is going, which are the forces that are responsible for the motion of these forces. I don't have any answer, even I'm not eager to find out the reason. So this is the kinematics. Okay, now let's come to the frame of reference, a very important topic. That is how we can say it is a system of coordinate axis with respect to which an event can be described is called a frame of reference. This is the definition. First go through this. It is a system of coordinate axis with respect to which an event can be described is called frame of reference. Yes, in a non-technical terminology, when I say it's a non-technical terminology, that means you can use these things for your understanding purpose only. You are not going to write these things in your examinations. Okay, are you clear with this? This is for the understanding purpose only. May or may not have a logical meaning to it. So what is frame of reference? I can write like that, that it is a platform from which observations are being taken. It is a platform from which observations are being taken by an observer. So, for a definition, you should use it. For understanding, you should use it. So, what I can write is it is a platform from which observations are being taken. Now, let's come back to the question of people sitting in the bus and people standing over the bus stop, because according to the passengers in the bus everyone were at rest, and according to the people standing over at the bus stop, the passengers are in motion. Now, when I can say that when these people said about each other that this are at rest, this all are at rest. Why? Because they are having a frame of reference, they are having a frame of reference of bus. It is the platform from which observations are being taken. While the people standing over the bus stand, their frame of reference, their frame of reference is Earth, and these are not moving. This people having a frame of reference. This people having a frame of reference. FOR stands for frame of reference is bus. So both are on different frame of reference. Both are on different frame of reference. So when both are at a different frame of reference, they can have a different observation. So let's see how the sets of motion and state of rest are related with each other. We can say this: these two are, rest and motion are relative terms. They are not absolute. What does it mean is a body can be at rest or in motion with respect to reference frame. So, shall I go back to the situation of a bus? A passengers sitting in the bus are at rest with respect to each other because their frame of reference is bus. But same passengers sitting in the bus were in the state of motion when we considered or when we observe the things from the people over here. Yes, so this is what it is. This two terms, rest and motion, are relative terms. Any object can be in a state of rest for some particular observer. A same object, I repeat, a same object can be in motion according to the different observers. Why? Because both the observers may be having a different reference frame, and when the reference frame is changing, status can be changing. So a person or a body can be at rest or in motion with respect to reference frame. Am I clear with this? Yes. There is no frame of reference. There is no frame of reference which is perfectly at rest. Even if you take an example, or if you are, let's say this is land, you are here observing certain situation. So I should say this is earth. Yes. If you consider this frame of reference, if you consider a frame of reference as an earth, even earth is moving. Yes, earth is rotating around its axis. Earth is rotating around the sun. So there is no frame of reference which is perfectly at rest. Are you clear? So let's go through this. A man in a moving train, a man in a moving train is at rest with respect to its co-passengers but he is in motion with respect to a man outside the train. This is the same case that we already discussed as compared to the bus examples. Are you clear with this? Are you clear? Are you sure? Okay, let's check it out. Certain MCQs based on this concepts. A particle is an object having negligible. What is it? Yes, it's a dimensions. A particle is an object. A particle is an object having negligible dimensions. Next, rigid body. Rigid body is a combination of particles, and when external force is applied, there will be no change. What is not going to change? Magnitude, dimensions, magnitude and directions alone. Yes, they are not going to change its dimensions. When an object does not change its dimensions, when an object does not change its dimensions, it is said as a rigid body. Yes. Okay, next. Rest and motion. What are they? What are they? They are the relative term that we know. But as per the options given, it is not absolute as well. So answer, this two are correct. So answer should be this. Rest and motion are not absolute term, and when we say not absolute, we mean relative term only. Yes. Okay. Now let's go through the different types of motion. This is a motion in a straight line. This is a motion in a straight line. Look at this. Can you see the crawling ants? Yes, they are moving in single direction only. Look at like this. They are moving in single direction only. So this is motion in a straight line. This is motion in a straight line. Or how can I define this? How can I know that this is motion in a straight line or something like this? Let's look at one more situation. Let's say a ball is there. You throw it upward with certain velocity v. This ball will move on this direction, and after traveling a certain distance, that means after achieving certain height, due to some reasons, it will moving backward in this direction. So does it a motion in a straight line? Does it? Or only direction in x? Or only, let's say, you might know this is x, this is y, this is z dimensions. So what is motion in a straight line? I should write like that: if a particle changes only one dimensions, either x or y or z. If a particle changes only one dimension, then it is moving in straight line. Then it is moving in straight line. Are you clear with this? Let's say this is motion in the x direction. So they are moving in x only. They are not moving in y. Let's say this is motion in y direction only. This is motion in y direction only. So here this ends are changing their x dimensions only. X dimension only. This ball is changing its y dimensions only. So this can be considered as a motion in a straight line. Are you comfortable with this? Yes. Next. Next. What is it? It's a cockroach moving on a floor. Will you be able to move? Yes. But don't worry. Yes. This is quite possible that, let's suppose this is x, this is y, and this can move like this can move like this can move like this. It is its wish where to go. Where to go. Yes, you can consider this as an x dimension and this is y. This is a plane. This is motion in a plane. Or rather I should write it like it's a motion in two dimensions. Motion in two dimensions. This is motion in 2D. When I talk about the motion in 2D, what it would be? Look at this. Let's say cockroach was at this place. After a certain time, it is at this place. So he has changed its x dimensions as well as it has changed its y dimensions. After some time, let's suppose it is at this dimensions. This is its initial position and this is its final. Now again it has changed its x dimensions and it has changed. Let's say I'll write this as an x2 and this is y2. So it is changing its dimensions or its coordinates in x as well as y. So if particle if particle changes coordinates of any two axes, then particle is said to be moving in plane. Got it? Here it is moving in two dimensions, either xy. Even you can take it as an x and z or y and z. But if it is moving in two directions, if it is moving in if in two dimensions, then it is said to be in a motion in a plane. Are you clear with this? Okay, now let's look at the next situation. Can you see this? Yes, it's a flying honeybee. What type of motion is it? Yes, this is motion in a space. This is a motion in a space. Yes, look at this. This is, let's say this is x, this is y, this is z, and it is moving in all the dimensions. It is changing its dimensions in x1, y1, z1. Let's say it has started from x1, y1, z1 and it is ended up by x2, y2, z2. So it has changed its dimensions. It has changed its dimensions in 3D. So this is motion in three dimensions, or rather I should say this is motion in a space. Are you clear with this? So up till now we have discussed about the motion in 1D, motion in 2D, motion in 3D. When object changes its dimensions in one dimensions only, it is a motion in 1D. When object changes its dimensions in a plane in two dimensions, it's a motion in 2D. And if object changes its dimensions in all three dimensions, then it's a motion in 3D. Are you clear with this? Let's revise this. It's a motion in a straight line, motion of an ant, motion of a cockroach can be considered as a motion in a plane, and a motion of a honeybee can be considered as a motion in a space. Are you clear with this? Yes? Are you clear? Okay, let's go through the MCQs. How many types of motion are there? One dimension, two dimension, three dimensions. Three kind of motions. Next, motion in one dimension is also called, what is it? What is it? Motion in one dimension is also called as a motion in a straight line. Is also called as a motion in a straight line. Next, let's move to the rectilinear motion. What is it? What is it? While I say rectilinear motion, which means recti stands for straight and linear stands for line. So it is a motion along a straight line. It is a motion along a straight line can be considered as a rectilinear motion. Look at the car. It's a motion of a car which is moving on a straight line. So it is a rectilinear motion of a car. It is a rectilinear motion of a car. Are you clear? Yes. Look at this. what you can observe, look at this. Here what was the situation is, this is x, this is y, and in next slide, in next situation, I have just to rotate my x and y. Let's say this was x, this was y, and in next situation I have rotate my x and y axis. So in this situation, car is having a rectilinear motion. In this situation, car is having a rectilinear motion. Even in this situation, car is having a rectilinear motion. So we must understood that rotation of coordinate system does not change the rectilinear motion of the car. All the rotations, all the coordinate system are our consideration only. Our consideration only. Let's say by practice you are using this is x, this is y. But if you wish, this could be a z and this could be a y. In that situation, this would be considered as an x. So we have designed the coordinate system for our purpose. There are no stringent rules associated with it. So when you are changing, when you are changing, or rather I should say when you are rotating your coordinate system, that does not change category of motion for an object. Are you clear? Yes. Next, move to the path length and speed. But before this, we want to know about two different categories of quantities, two different categories of physical quantities. One would say one should be a scalar and another should be a vector. Now, what are the scalar? They are the quantities with magnitude alone, and they are not having a directions. What are they? The examples would be the path length, speed, next, next, next. Quantities with magnitude alone, but they must not be having any directions. Temperature, yes. Anything else? Anything else? Think and let me know. Mass, very good. Next, energy, yes. Go on, and etc. Now, vector quantity. What I can say, which are the vector quantities, or what should be the conditions? What should be the conditions? The first conditions that we learned in previous classes is, they are the quantities with both magnitude and direction. Both magnitude and direction, we have learned up to this, that what is vector, then we immediately say that it is the quantity which should be having magnitude and it should be having a direction as well. But a complete definition would be that it should be having magnitude, it should be having direction, as well as it should follow laws of vector addition. If it is having these three things, one is the magnitude, another is the direction, and it follows laws of vector addition, then and then it could be considered as a vector quantity. Please remember these things. If it is having these three things, it is having magnitude, it is having a direction, and it follows laws of vector addition, then and then it can be considered as a vector quantity. Which are they? Which are they? Think. The other, displacement, velocity, next force, yes, next, next pressure, pressure, no, pressure, if you are thinking it's a force by area, but this is not a vector, this is a scalar. So do it, that if force is a vector, doesn't mean that pressure would be a always a vector. You cannot think like this. Got it? Okay. Next vector quantity, it's an acceleration. Yes, you are correct. Acceleration would be a there. Comes into the category of the vector quantity. Next, next, next. Think a little. Next. What it would be? Field? in previous classes you might be studying about the electric field or in magnetic field. This all fields would be the vector quantity and etc. So are you clear with the scalar vector? Yes. Now let's check it out. The two quantities, they are the path length and another is the displacement. First, let's begin with the path length. Let's begin with the path length. What is path length? I can say is that is the total distance traveled by an object from initial to final position. While considering path length, you need to remember these words. You need to add up all the distances that you have traveled. You need to add up. You need to add all those distances which you have traveled. That is what we call as in path length. It is the total distance traveled by an object from initial to final position. And next, what is displacement? What is displacement? It is the shortest distance between initial and final position. It is the shortest distance from initial to final position. Are you clear with this? Now let's look at one of the example. Suppose initially you were at home, then you go to the college, and from the college you move to the McDonald's. But you don't go to the McDonald's in this situation. Okay, stay at your home, stay safe. Now let's back to the question. What was the situation? The situation is you were initially at home, then move to the college, and then to the McDonald's. So if someone asks me what is the path length, what I need to do is I need to add this distance. Let's say this is x1, let's say this distance is an x2. So if I add this to x1 and x2, that is the path length for me. That is the path length for me. And someone asked me what is the displacement. So my initial position, initially I was at home, and I was I was at the McDonald's. So it is the displacement. While I consider the displacement, I need to consider the final position minus initial position. Finally I was at McDonald's and initially I was at a home. So it is a difference between these two positions. Are you clear with this? Are you sure? Okay, let's look at this new situation. Let us suppose initially you were at home and you don't go to the college, you only go to the McDonald's. So what is the path length? What is the path length? It's a distance from home to the McDonald's. Now one more question, what is the displacement? What is the displacement in this case? Yes, it is same. It is the initial position, this is final position, and there it is the difference, final minus initial, it is the displacement. So in this case, in this situation, path length is equals to displacement. This, in this situation, it is the path length which is equals to displacement. Are you done with this? Okay, now let's look one more question, one more situation. Let's say this is the initial position, this is the final position. You were about to start from the home, you will reach to the McDonald's, you will reach to the McDonald's, and from home to the McDonald's you will again go back to the initial position, that means go back to the home. So situation is this is initially, then you reach to the McDonald's and again come back to the initial position, that means home again. So what is path length? Let's say this is distance x. So distance from home to McDonald's, that is on a one way, and on a other way, that is x. So total distance or the path length covered is x plus x. But what is the displacement? What is the displacement in this case? Think. Yes, your initial position, your initial position and final position are equal, and when they are equal, displacement would be a 0. Are you done with this? Yes. Can you get this? Okay. So let's go through a very good conclusion. They are the magnitude of displacement may or may not be equal to the path length traveled by an object. How this is possible? Tell me. Now let's go back to the questions again. In this situation, you were here and you just ended up at the McDonald's. You are not coming return back. In this situation, the path length is, let's say this distance x. Displacement is again at this distance. So in this case, path length and displacement are the same. In this case, path length and displacement are same. In this situation, you were initially at home next to the McDonald's and coming back from McDonald's to the home. While you coming back to the home, your initial position and final position are equal. And when initial position and final position are equal, displacement is 0. But if I am talking about the distance, or the, I should say, path length, then it is 2x. Then it should 2x. So this is the magnitude of displacement may or may not be equal to the path length traveled by an object. Yes, in first case it was equal, in second case it was not. So when path length and displacement, or magnitude of displacement, would be equal, can you conclude anything from this situations? You might get it right, that when object is moving on straight line without turning back, distance traveled would be equals to magnitude of displacement. Distance traveled should be equal to magnitude of displacement. So this two would be equal. If a particle is having a u-turn, or if an object is having a u-turn, then displacement or magnitude of displacement and distance traveled could not be the equal. Next, one very good conclusion is the magnitude of the displacement for a complete motion, magnitude of the displacement for a complete motion may be 0, but the corresponding path length cannot be a 0. Let's look at this situation. This is a circular path having radius r. This is the initial position. Let's say you started with this, move this, and ended up at this position. And you ended up at this position. That means your initial position and final position is equal in this situation. So what is your displacement? What is your displacement? Yes, it is 0. Okay, if someone asks me what is the path length, what is the path length, I should say that I have started from here and ended up here. I have been walking on a boundary itself, and if I need to calculate boundary of a circle, it is nothing else but it is a circumference of a circle. Yes, oh yes, it is circumference of a circle. Now what would be the relation of circumference of a circle? It is 2 pi r. Yes, good, you did it. So in this situation, magnitude of the displacement for a complete motion may be 0, but the corresponding path length is not 0. This all points and this all conclusion are very very important, while they are going to ask a certain theoretical but they are very tricky questions. So you need to remember each and every case that we have discussed here. Yes, let's move to the question and answers. Go through this. Go through very carefully. You need to do this on your own only. Go through this. What they have been asked is correct the statement. You need to find out the correct. Among the following, when displacement is 0, distance traveled is not 0. You need to find out the correct statement. When displacement is 0, distance traveled is not 0. Is it possible? Okay, let's look at the new options. When displacement is 0, distance traveled is also 0. This is not the case as always, so this would be the incorrect. When distance is 0, when distance is 0, displacement is not 0. This is the false. If distance is 0, when distance would be a 0, as object is not moving. If object is not moving, displacement must be 0, and the option is saying displacement is not 0. That's why it is incorrect. Next, distance traveled and displacement are always equal. This cannot be the case. Let's look at this. This is initial position, this is final, this is position B, and from having a U-turn you are about to reach here. Let's say from A to B it's a 10 meter, from B to C it is let's say this is 7 meter. What is the distance? What is the distance? If I have been asked what is the distance, it would be a 10 plus 7. Yes, it's a 17. Now what is the displacement? Tell me. What is the displacement? It is 10 minus 7. Yes, equals to 3, because this is the initial position and this would be the final position. You need to just calculate a distance between initial position and final position. It is a displacement. So distance traveled and displacement are always equal. Word always make it incorrect. If they are having an word maybe, if they are having an word maybe, then this would be absolutely correct. So in according to the this question, when displacement is 0, distance traveled is not 0 is the correct answer. Yes. Look at the next question. The numerical ratio of displacement to the distance. Displacement to the distance. They are asking for this. If an object are moving in a straight line, if an object are moving in a straight line without having a U-turn, without turning back, this could be the equal. But 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 if they are in motion where they need to turn back, then displacement would be less than distance. Shall I write this? If a motion having no U-turn, then displacement should be equals to distance. But if a motion having U-turn, then displacement would be less than distance. Displacement would be less than this. So ratio of this could be less than or equal to 1. Are you getting this? Yes. These are very interesting kind of questions. Yes. Next, the total distance traveled by an object from initial to final position. The total distance traveled by an object. Total, they ask about the total. They are not talking about the virtual. The total distance traveled by an object from initial to final position is known as the path length. This is the path length. Yes. Are you done with this? Let's look at a very good question. What they have been asked is that an aeroplane is there which is moving 400 meter towards the north, 300 meter towards the west, and 1200 meter vertically upward. Seems interesting. Then its displacement from the total position. Let's look at this first. This is north, this is east, this is west, this is south. You know this news, na? Are you sure? It's a NEWS, news. So this is north, east, west, south. Okay. So what the situation is, an aeroplane moves 400 meter towards the north. Let's say this is the initial situation and this is the 400 meter. Suppose. Then 300 meter towards the west. Then it would be in this direction. And 1200 meter vertically upward. Now don't make a mistake while moving 1200 meter in this direction. This is not an upward. This is not the case while you are thinking. So they have been asked about the 1200 meter in upward direction. They have been asked upward direction. So when they said it's an upward direction, they mean to ask that they are moving 1200 meter in the direction which is perpendicular to the plane, which is perpendicular to the plane. Are you get it? This is, let's say, y direction. This is, let's say, x. In a correct manner it is minus x. Then I need to move 1200 meter in z direction. Did you understand things? Are you sure? So what they have moving is in x direction 300 meter, in y direction 400 meter, and in z direction they are moving 1200. And you need to find out the displacement. How could you do this? In 10th class you might be knowing this. This is when an object is moving in 3 dimensions, it should be an x square plus y square plus z square. Yes. So this is equals to, let's say this is 309 plus 400, this is 16 plus 12, it's in 144 multiplied by what it would be. So this would be multiplied by whatever it would be, multiplied by 100. First let's solve this. 144 plus 16, it's 144 plus 6, 150 plus 10, 160 plus 9, 169. So this is, if I make this value out of the square root, it's a 13 and it is multiplied by 100. So this is 1300. Are you getting it? If not, now let's look this as a different aspect. Look at the room in which you are sitting. It's a something like cube kind of thing. Whatever the room, it would be a cube kind of thing. Let's say you are at here in this position. Now you are moving in this direction and then on this direction and at last on this direction. Yes, you need to look at the one of the top corner and other bottom corner of this room. One of the topmost corner and other bottom corner. Let's say this is A, even this is A. It's a cube having the same dimensions. So if I need to calculate this distance, then this should be a root 3a. How this has been arrived? By this only. Please do remember this thing. I hope these things are clear. Yes, very good. Now let's move to the next question. I said that these are the very interesting questions. So let's look at this very carefully and do this. They said a body completes one round of a circle of radius r. The radius is given r, and within a time frame of 20 seconds. The displacement, they have asked about the displacement of the body after 45 seconds. So let's look, this is the situation. Maybe they have started from here. They are moving having an one revolution, another revolutions, and still going on. But we need to observe our situation at 45 seconds. So what would be the situation? Let's say this is circle and this is the radius r, and from here particle must have started. If they have completed one revolution, if they have completed one revolution, they would require a 20 seconds. If they have completed a second revolution, they have taken another 20 seconds. Now you have a total time frame of 45 seconds. So you are left with 5 more seconds. You are left with 5 more seconds. In 5 seconds, what you could travel? Tell me. So what could be the situation if I could split this circle in 4 parts? I require 20 seconds to cover 4 sections. Can I say this? So in 5 seconds, I can cover only a one section. So at 45th second, particle should be at this place. Now again, reconsider this situation. You have started initially with this, started moving, and by 20 seconds you have completed your first lap. Moving onwards, by second revolution, you have ended up with 40 seconds. Now you have 5 more seconds. So you are at this position. Now you need to calculate the displacement. So the things would look like this. This is the circle. This is your initial position. This is your final position. This distance is r. This is r. And you need to find out the smallest possible displaced distance between these 2 points. What it would be? Can you see right angle triangle over here? Yes, you think it correctly. This should be the minimum possible distance available. This should be the minimum possible distance available. Now this is r, this is r. Let's say this is a, this is c. So AC, and let's say this as a b. AC should be equals to under root of AB square plus BC square. Now AB square, it is r square, BC square, it is r square, so that should be root 2r. This is displacement. This should be the displacement. Now can I add one more thing? Can I add one more question at this place? Can I? If they have been asked, find out distance, find the distance traveled in 45 seconds. So if I write like this, in first 20 seconds it has traveled one circle, so it is a 2 pi r. In next 20 seconds it has traveled 2 pi r again. In next 5 seconds it has traveled only a one section, so I should write it as a 2 pi r by 4. And when I write like this, it would be an pi r by 2, that you know. So total distance should be 2 pi r plus 2 pi r, it is 4 pi r plus pi r by 2. I can write this as 8 pi r plus pi r, this is 9 pi r by 2 in meter. This is total distance traveled. Yes, yes. Can you do this on your own? Are you sure? Let's look with a new question. Go through this. What they have been provided is, they say that a body is moving along the circumference of a circle of radius r, and they have completed half of the revolution. Then the ratio of its displacement to the distance, they require the displacement to the distance. First, what is the displacement when particle covers half of the revolution? This is initial, let's say. This is final. So it is the shortest distance is directly diagonal of the circle. So it's a 2r. I hope this is clear. Next, they require a distance. What is distance covered when particle is moving along the circumference of a circle? Boundary. If you are about to complete circle, it would be a 2 pi r, but here it is half of the circle, so it is, I can write like this, 2 pi r by 2. This is pi r. If I take a ratio, if I take a ratio of displacement to the distance, this is displacement to the distance, it is 2r divided by pi r. R would be a cancel and 2 is to pi would be the correct answer. I hope this is clear to you. Sure. Now let's move to the last question of today's class. They say a body is moving in a circular path of radius r in 10 seconds. Let's make a diagram of this. This is the body moving in circular path having a radius of r in 10 seconds. The ratio of the magnitude of displacement to the distance traveled after 5 seconds. Now, can you judge the situation? They said that if you are starting with this point A, you can move through complete circle in 10 seconds. You need to find out what would be the situation after 5 seconds. So after 5 seconds you would be at this position, directly or indirectly. This is the previous question only. So what is your displacement? Now tell me, what is your displacement? It is 2r. What is the distance? It is pi r. You require a magnitude, ratio of magnitude of displacement to the distance. So if I take a ratio of this, it's a displacement to the distance, it should be 2r divided by pi r. R would be the cancel. 2 divided by pi, what is it? It's a 22 by 7. Can I write like this? Yes. So this is 7 is to 11. This would be the answer. Yes. Are you done up to this? Comfortable with this? Okay. So let's wind it up. What we have discussed up till now is, we know what is kinematics. We know what is motion in 1D, motion in 2D, motion in 3D. Before that, we have gone through what is motion and what is rest, how reference of frame defines a state of motion, and then distance and displacement. Yes, you must be clear with this. This all has been covered in class 9. This is just a revision kind of class. So you must be able to solve each and every questions that are related with the distance and displacement. So please do one thing, go through your material, go through this class notes and go through the questions. Practice as many questions as possible. Okay, let's bye bye. Bye bye. Take care. Have a good day.